is on half-life calculations. So a half-life is the amount of time required for half of a sample of a radioactive isotope to decay. So you've learned about this in math. All it is exponential decay. So we're going to see how we take a sample, and it's going to decay over time, and every so often, the time of a half-life is going to get cut in half. So let's go through an example. You have a piece of uranium that has a mass of 100 grams. After 5 minutes, how much is left if the half-life is 1 minute? So our initial mass here, we're going to call Mi, is 100 grams. Our total time, capital T, is 5 minutes. And the time of our half-life, T1/2, is 1 minute. I want to know what is my final mass, which is Mf. So we can make a chart to help us see it. At a time of 0, the amount of uranium I have is 100 grams. After 1 minute, the time of my half-life, my uranium sample decays by 50%. So 50 grams are left. It's divided by 2. Within my next minute, 50 gets divided in 2 again to 25 grams. Divided in 2 again, 12.5, and again, 6.25, and finally 3.125 grams. So my final mass of my uranium that's remaining after 5 minutes is 3.125 grams of uranium. If I notice when I do this, every time I'm dividing by 2 to get from one to the next, to the next, to the next. So if we were to do this using a mathematical equation, we could write 100 divided by 2, divided by 2, divided by 2, divided by 2, and divided by 2. So we divided 100 by 2, 1, 2, 3, 4, 5 times, which gives us 3.125 grams. We can also write this another way, which is 100 divided by 2 to our number of half-lives that we had, which is 1, 2, 3, 4, 5 half-lives. So 2 to the 5th. If we plug that in our calculators, we get, again, 3.125. 2 to the 5th is 2 times 2, 5 times. Let's go through an example without using a chart. I'm told the half-life of nitrogen is 10 minutes. So T1/2 is 10 minutes. If the starting sample has a mass of 2 grams, my initial mass, 2 grams, how much will remain after 40 minutes? So my total time, 40 minutes. I want to know how much remains, and I also need to know how many times I had a half-life. We're going to call that N. So if my total time was 40 minutes, and it took 10 minutes for a half-life to occur, my number of half-lives is going to be my total time divided by the time of a half-life. So that is 40 divided by 10, 4 half-lives. That means that my sample of 2 grams was cut in half 4 times. So my sample of 2 grams was divided by 2 4 times. So 2 divided by 2 is 1, divided by 2 is a half, divided by 2 is 0.25, divided by 2 is 0.125 grams. Example 2, if I have 200 grams of an isotope, so my initial mass, 200 grams, I decay to 25 grams, so my final mass is 25 grams, in a total time of 24 seconds. I want to know how long it took to get through a half-life, and I also need to know how many half-lives I had to determine the problem. So starting with my original amount of 200, I need to know how many times it got divided by 2 to get to 25. So I start my first one, 200 divided by 2 is 100 grams. Not what I want. So I do it again. 100 divided by 2, which is 50 grams. And again, 50 divided by 2, 25 grams. That's what I want. So that means it took 1, 2, 3 half-lives to get from 200 to 25. So N equals 3. So that means within my time period of 0 to 24 seconds, I cut it in half once and again. So that means that some amount of time occurred 3 times, 3 half-lives, to get to 24 seconds. So my time of my half-life is 24 divided by 3, which is 8 seconds.